Welcome back, ladies and gentlemen. Today we're going to model this foam cup as shown in the drawing provided. You can see here in this multi-view drawing that we have a foam cup. You can see the dimensions, a front view, a top view, an isometric view, and a right side section view. So a section view has been created, cutting here at the plane shown by the line FF, and this area right here has been removed, and we're now looking into the cup from the side. I'm going to take a moment to look over the model we're making. So this is what the model is going to look like when done. You can see it looks like any other cup. Now this is a revolve feature, which means that it spins around an axis. So quick overview, we're going to go ahead and create this sketch of 1/4 of the cup, or at least what 1/4 would stamp out if you use it like a rubber stamp on the table. Let's create just this section area right there, and that is visible in yellow. Then we're going to use the revolve tool, revolve around this axis, and that will give us, we're going to revolve full 360 degrees, and that will give us the final cup, just like you see here. So important things to understand is we have to understand section views in this exercise. So a section view is a cutaway view. And you can see here, we're cutting into the model. So there's the full width model, and we're going to be cutting in halfway through and looking at it right there. We will draw just 1/2 of the section view in order to get this revolve feature going. So without further ado, let's take a look at what we have. So again, we're provided these, and we have our overall measurements, and we have our section views. Now looking at the drawing, you can see the dimensions are split over 3 of the 4 views shown, and we want to really kind of compact them into one space. So what we're going to do is we're going to go ahead and look here and see which of these measurements can be transferred over to our, and how they need to be transferred over to our sketch. So you can see here that the 3-inch diameter, or the outer diameter, is the widest part of the cup, is the distance from this point to this point. Over here in the right side view, you can see it's also from here to here. So it's the outermost point on the right, outermost point on the left. That distance is 3 inches. We are going to draw this just half of that. So that means we need the radius, we're given the diameter, and the radius of a circle with a 3-inch diameter is 1/2. So I'm going to go ahead and add to our, just take our pencil and sketch in there the dimension that we want, which is 1/2. And then we go back to our model here, our drawing. You can see on the front view of the cup, we see a 2-inch diameter for the base and a 3.5-inch height for the object. So that 3.5-inch height is just going to transition straight over, top to bottom, and then this 2-inch diameter base will work out to be a 1-inch radius for the base. So on your papers, you can go ahead and sketch those dimensions on there. So just pencil those in like this. So now you can see all of the dimensions. There are a couple other notes on here we want to pay attention to. You'll notice it says, note all fillets 0.1. So there are a couple fillets in here. If we zoom in, oops, wrong slide. If we zoom in, you can see there is a filleted edge, a rounded edge on the inside of the base of the cup. And that is what we're talking about, that fillet 1 inch. We are given the material being foam core and the mass 0.074 pounds. Another thing that's a little bit different, you can see here the dimension for the wall thickness is telling you that's 0.10 typical. So that's a measurement of the wall thickness, saying that typically throughout this model, we can anticipate a 0.1 inch wall thickness. You can also see the base is 0.1 inches. Roll on over to the next slide, and you can see that that has been repeated, so that there's the 0.1 inches that carries through the base. We also have a height shown here for the top of the round at 0.125, an eighth of an inch. And that, like we talked about already, the radius for the base of the cup is 1 inch. So let's head on over to our OnShape, and let's go ahead and hide this. We'll create a new sketch on the front plane. Rotate to your normal position. So tap the M key on your keyboard. And we'll just go ahead and start by penciling in the straight lines that exist in our model. As a matter of fact, I'm going to split this down to a slightly smaller window so we can, come on. You got to do this side by side view. There we go. A little bit forward. There we go. All right. So here we look at it. We need a line. We need a line that is vertical. That line is going to be 0.1, as we identified earlier. The wall thickness of the cup is a typical dimension of 0.1 inches. So that's our thickness of the base of the bottom. We have two radii here and a flat section. Let's go ahead and draw the flat section first. Drop on down. And that line, go ahead and throw in there 0.1 while we're at it, just to get some, oops, not 1, 0.1. All right. And we can see that the distance, vertical distance between, oops, over there. The vertical distance between this horizontal section right here and the top of that arch is an eighth of an inch, 0.125 inches. So we'll roll on back. Oh, not the right one. Oh, not the right one. Where the heck did I lost my OnShape? There it is. Okay, I lost my OnShape again. Sorry about that, folks. Lost my OnShape again. There we go. So here we are. So we're going to draw this arch right here. I've got a horizontal line and a vertical line. And so the dimension from the bottom of this one to here, according to our drawing, is 0.125 inches. Now again, where am I getting that? Right there, you can see 0.125 inches. There's the extension line pointing over to the bottom of the arch, and then the absolute bottom of the cup. And so there's the flange that it sits on, the foot, the rim, bottom rim of the cup. We can go ahead and connect this one to this one with an arch. So let's go ahead and get our 3-point arc tool and point to point, and we'll just leave that there for right now. And escape out of it. I don't really not worried about the radius. We do need to add a second arc, 3-point arc. This one I don't really know where it's going to, but I do know that we have a uniform thickness. So I'll put a single point like there we go. So I do know that there's a uniform thickness. If this is uniform thickness, that's what the instructions told us. It's typical. Let's roll back there. And you can see that the dimension provided in your drawing tells us that thickness is typical, okay, a 1/10 of an inch. So that means that the base is going to be 1/10 of an inch as well. Let's roll on back to that. So escape out of there. So if this is uniform thickness, that means these are concentric circles. I'm going to go ahead and grab the concentric constraint and make these two circles arcs concentric with each other. That means they share the same center. So they're going to be hanging out like that. Okay. Now let's go ahead and shorten this for a moment and draw the side wall of our cup. So looking at the cup, it comes across, and we have the arc sort of here, and then it comes up at an angle. We've got two straight lines going up 3.5 inches. So let's go ahead and put that in place. Take our line tool from here up, double click, single click, and you can see the parallel constraint symbol popping up. There's two lines at an angle side by side, the parallel constraint. I don't want these two lines to be ended the same place because you can see over here that they don't. So I'm going to drag the inside one farther than the first. We'll double click. You'll notice there's a radius here. That's a fillet. We'll add that with the fillet tool in a moment, but I wanted to get these lines drawn first. Just a little easier to do it that way. I can go ahead and close this loop with the line tool. So it's horizontal. So it's horizontal. We're going down parallel to the inside. So parallel to that. And it does appear to be a horizontal line there. So we'll go there and there. And that closes our shape in. We don't have our dimensions on it yet, and we're still missing our fillet. So let's go ahead and grab that fillet at 0.1. So take the sketch fillet tool, zoom in, select the inside radius. I'm going to single click and 0.1 inch. So there you go. There's our 0.1 inch radius. That's a fillet, so it'll be a smooth transition. It's looking pretty good so far. We can see that there is a distance we skipped over. There's a dimension here of 1 inch across. We'll take the dimension tool and measure from here to here. Now we got a 1 inch measurement. And now one thing that's a little odd, notice that my arc, they're not really looking the way it's supposed to look. You can see over here that there's a nice smooth sweep, and my radius doesn't seem to be wanting to look good. I want a smooth arc all the way across, and in order for get a smooth symmetric arc, the center of that arc needs to be on this axis. So I'm going to try, so this work vertical, get that lined up with the origin, and that worked. It did throw me into a weird situation with that, but I can just pull that back. So there you go. Vertical rules. Now the distance between these two side walls is 0.1, so we can mention the distance between those. So click on the middle of the line there, so we click on the middle of that line, and one. Ooh, not 1.1. Control Z is your friend. Don't be afraid to undo your attempts. That doesn't hurt you. I'm going to escape that. So we're getting a lot closer to being done here. The overall height of this thing is 2.5. Let's slap that on there. So from the base to the top. And make sure we got vertical straight. 2.5. And then we look over here, we can see the thickness of the outer rim is 0.2 from here to here, so let's go that. 0.2. The height of the sidewall rim there is 0.3. And that is along, you see that measurement is along the side, not just straight vertical. So 0.3. And the last dimension we haven't used, let's check, all right? We have used 1/8 for the top of the arc. We've used the 1 inch across. We have not used this dimension. Let's go and see what happens here. 3.403. That looks like it wants to be driven. If I try to, that's the same. So I'm just going to hit the enter key. You see that provides a driven dimension there, so that matches. If you try to type in a number, change that to a driving dimension, you'll see that'll turn red. It's like I didn't need that dimension at all, so just leaving it as a driven is a good option. Now we're going to roll in here and get that. We did that, so we have the thickness of the foot, we have the outer diameter. Always try to make the dimensions neat. We have the radius, we have that radius, we have the radius of the thickness of the wall. We have the height of the flange, the width of the flange, we have the height of the cup, we have the thickness of the flange, and we are only missing right now the radius of the rim of the cup. So dimension tool and go from the origin to the outer part of the cup. And we need that radius at 1.5. And you can see that our sketch turns black, so that means that our cup is fully constrained. And hopefully, that should revolve for us. Shouldn't be a problem, so we have the revolve button. It's asking for our face and sketch region revolve. There it is. Revolve axis, like we said in the beginning. Right there. There is your cup. Looking pretty good. Let's go ahead and rename our cup. Cup. Green check. Let's rename the part. Our drawing tells us that we have a material assigned, foam core, and a mass of 0.74 pounds. So we just add that material, check our mass. We'll see whether we did it right. So right click, assign material, change the material from none to foam core, assign, display your mass properties, and you can see that our mass is checking out at 0.074 pounds, which matches what our drawing tells us, and we have a cup. So properly solve this exercise. Good luck, have fun, and as always, keep being awesome.